this video, I'm going to use the Gauss-Jordan method to solve a system of equation. So in this one we have three equations, three unknowns, of which we can actually use a set of preliminary steps before we even begin. And sometimes we can do simple stuff like switching rows or equations and whatnot, or maybe we can simply just divide by a constant. Um, Now, in any case, you don't really need to do these types of preliminary steps, but sometimes it may or may not, simplify the process at least. And this is just really an exploration on that thought. So, like for instance, let's say that we divided equation 2 by 2. So in that case, we would have that the same system would exist. You'd still have 5x minus y minus 4z equals to 14, but you would end up with 3x plus y minus 4z, and then that's going to be equal to 10. So in any case, we didn't really do much aside to just dividing equation 2 by um, 2. So we still have what we call an equivalent system. Okay, so in any case, nothing's really going to change so far. So the next thing that I would like to do is to look at equation 3. Okay, and again, this is really just preliminary, and it's more or less just a trick. So let's say that we take 8x minus 7y plus z equals to 23. We go ahead and we solve for z, and we want to know like what do we get from there. So if we solve for z, we're going to get negative 8x plus 7y plus 23. Okay, now in this case what we want to do is substitute this equation into equations 1 and equation 2. Okay, so what that means is that, for instance, you're going to have 5x minus y minus 4 multiplied by negative 8x plus 7y plus 23 equals to 14. Now, in any case, we can actually simplify this, and that's going to give us 5x minus y plus 32x minus 28y minus 92, and that's equal to 14. Now, notice that furthermore, you could actually simplify even further. So for instance, you have 37x minus 29y equals to, well, 92 plus 14 is 106. So we have that that's equal to 106. Now notice that this is actually just giving us just the first equation, but in terms of x and y now, of which this is going to be useful once we get the other equation down to just one single, two variables actually. So let's now try the second equation, where we'll go ahead and say, well, we have now we have 3x plus y minus 4, and this is going to be, let's see, 8x, let's write a little closer, 8x, and we said negative 8x actually, plus 7y plus 23 is equal to, okay, so it's equal to 10. Now, all that you need to do from here is to go ahead and add, or no, distribute. Okay, so we'll distribute, so we'll just write it again. So 3x plus y plus 32x minus 28y. And then from here, you have that that's going to be also negative 92. Okay, so we have that that's going to be negative 92, and that equals to 10. Okay, but simplifying this even further, you're going to find that that's going to be 31x, and that's going to be minus 27y equals to, and yeah, basically we're just combining like terms. So 92 plus 10, that's going to be 102. So we have that that's going to be equal to 102. Now notice that this is actually the second equation in two variables now. Okay, so we can actually put that together and then solve for both x and y now. But let me just correct this small error right here. That's supposed to be 35. Okay, so we have that that's going to be a 35. Now from here we can actually go ahead and then put these together as a system of two equations. So notice that now you have 37x minus 29y equals to 106, and then you have 35x minus 27y, and that's going to be equal to 102. Now, this would be a new system technically, but it's still it still is equivalent to your original that you started with, because it's still going to have the same x and the same y respectively. So now we can actually solve this problem. Now, in this sense, now we can actually just use the Gauss-Jordan method using the row operations. So in any case, we can actually go ahead and say, well, if we were to go ahead and augment the system, that will give us the starting the operation. So we have 37, 35 minus 29, 27, and then we just minus 27, and then we just put 106, and then we have 102. Now, in any case, we need to eliminate 37 and 35, but you'll find that their least common multiple, in any case, in order to cancel out, would have to be their product. So we'll just put that the least common multiple between 37 and 35, that's actually equal to their product, which in this case is 1295. Okay, so what that means is that we need to take row 1, and we're going to multiply row 1 by 35. So we have row 1 times 35. And then we're going to take negative 37, and we're going to multiply that by row 2. And that's going to give us a new row 2. Okay, now I'm actually going to do this a little differently in the sense that I'm going to list out the elements, so that way there's no confusion as to like where did that come from. So we're going to take 35 times 37, which we already know is 1295, but we're also going to multiply negative 29, so we just need to find negative 29 times 35, of which this gives us minus 12, not 12, but 10, 15. Okay, but we also need to do 35 times 106. Okay, so 106 multiplied by 20, well, we said 35, right? Yeah, so 35. Okay, so that's 3710. And I'm working it out on a calculator over here, which, you know, I can show that computation if needed, like over here. Okay. So from there, we need to go ahead and take the other one, which is negative 1295. Okay, now what we're going to do here, because I'm multiplying by negative 37, so I need to figure out like what is negative 37 times negative 27, of which from there that gives us that it's positive 999. Okay, and then finally you're going to take your 102 and you're going to multiply by negative 37. Okay, so that's going to give you negative 3774. Now, I went ahead and, wrote it out like this so that way we see what those computations are when you combine them, because we need to know like what is row 2 going to come out to when we add. So when we add, we're going to get 0, okay? But we also need to find, as we go ahead and we combine like terms, we're going to add this negative 1015 to 999, of which it gives us positive 16. So we have, I'm sorry, not positive 16, but negative 16. So we have negative 16. Now, furthermore, we get the last constant by doing 3710, or 3710, minus 3774. Okay, so that's going to be 64. Negative 64. So we have negative 64. Now, this is the new row 2. So what happens is that your system becomes now 37, negative 29, 0, negative 16, and then we have negative 64, and then you have 106. Okay. Now, what we can do from here is actually go ahead and solve for the y variable. So in solving for the y variable, we can actually do that by multiplying by the reciprocal negative 116 times row 2 to give you a new row 2. From there, it's going to give you what y is equal to. So we have that that's going to be, okay, so we have 37, 0, negative 29. That's going to be a 1, and then you have that this is going to be a 16. Not a 16, I'm sorry. That's going to be a 4. So that's going to be a 4. And then you still have that that's going to be 106. Okay. Now, at this point, technically we can actually stop and solve for x, because we have that if we know what y is, then pretty much that tells us what x is. Then we can go back and then figure out what our solution is overall, x, y, and z. Okay, so in that case, if you want to stop here, you could actually is to back sub. Okay, but we're going to go ahead and complete it, since the whole purpose of this video is that you look at the full Gauss-Jordan method. And really, we're still using the Gauss-Jordan method, but we did use some preliminary steps as noted. So we have 29 times row 2 plus row 1. That's going to give us a new row 1. Now, in any case, if you want to look at, again, like what are the operations being done, you have that 37, negative 29, 106 is being added to 0 times 29, which is 0, and then you have 29, and then you have 116, it looks like. And when in doubt, we can actually always multiply that 4 times 29, of which is 116. Okay, so from here, all that we would need to do is to combine the respective rows. So that's row 1 and this is row 2. But we're just adding, okay? And I've already carried out the multiplication, by the way. So this gives us a new row 1, so that's 37, 0. And then this gives us actually the number, let's see, I think it's 222. Okay, so we have that that's going to be 222 as a new entry for that row. Okay, now let me just double check something real quick. Okay, so that means that we can actually now update our system. So updating our system, we have that that's going to be the following. We have 37, 0, 0, 1, and then we have 4, and then we have 222. Again, you can still use the uh, optional like back subbing because we know what x or we know what y is, so we can find what x is equal to. Okay, so the last thing that we just need to do is to take 1 over 37 multiplied by row 1, and that's going to give you a new row 1. Okay, so that's not too bad. Now, I'm just going to actually do the computation, off to the side where, I know that that's going to still be 0, 1, 4, and this is still going to be 1, 0. But, 37 into 222, that's actually equal to 6. Okay, so that's actually equal to 6. So that's going to be 6 right here. And, when in doubt, we can always, use our calculator for those big computations. So, you know, in the event that, you needed, then we can just divide this by 37. Okay, so we still get 6. Okay, now take into consideration that we just found what x, y is. So we know that x is equal to 6. We know that y is equal to 4. But now the question goes back to, well, what is z then? So if we kind of look back to our original question, we can find that z was equal to negative 8x plus 7y plus 23. But that would mean that we would need to, plug in x, y into this equation right here. Now, we could technically plug it into any of the 3 equations and then solve algebraically using the substitution, but we could actually use the one that we had. Okay, so we have that z. Okay, so z is equal to negative 8x plus 7y, and then that's going to be added to 23. So we have 23. Okay, but here we substitute everything. So we have negative 8 times 6 plus 7 times 4 plus 23. Okay, now in any case, we have that this is going to be negative 48 plus 28. Okay, so here you have plus 23, of which that's going to be equal to, should be equal to 3. Okay, because over here you're going to get negative 20 plus 23, which that's going to equal to 3. Okay, so that tells me that in fact the z is actually equal to 3. So now I have my complete solution, and we can actually represent that as an ordered triplet, or we'll just write solution is 6, 4, 3. Now consider like how long it might actually take if we were to solve the problem from the original system, you would have that you're going to use just as many steps, but you're going to notice that the numbers are going to get bigger if you're going to avoid fractions. However, of course, we could probably just plug this into our calculator, and if we do that, I think I already entered it in. Yep, I did. So notice that we can also check our work, or if we didn't have to show the process, then yeah, we could have just plugged it into our calculator, and then we just hit enter, and we get 6, 4, and 3.